Section 5.1, we were doing some antiderivatives, and the whole point was to try and find something that you can differentiate to get the integrand. So let's back up to problem number 22. I'm going to write it with x's as opposed to t's. So it'll be the integral of 4x squared plus 3 quantity squared dx. With integrals, there's no power rule, there's no chain rule, etc. So I can't add 1 to the exponent, divide by the same exponent. In order to find an antiderivative here, what I first need to do is I need to square this out. Can anyone square that out in their head, or do we want to do it by hand? All right, by hand, what you're going to do is take the integral, or the integrand, and multiply it by itself. So 16x to the fourth plus 12x squared plus 12x squared again plus 9. It's going to give me a total of 16x to the fourth plus 24x squared plus 9. So, okay. It's up to you if you want to split these things up. We can. Maybe I'll split this one up, but subsequent ones, maybe we won't. So I'll rewrite this as 16 times the integral of x to the fourth dx plus 24 times the integral of x squared dx plus 9 times the integral of 1 dx. But instead of writing it as 1, let me write it as x to the 0. The reason for that is because in finding these antiderivatives, it's just a simple process. You're going to add 1 to the exponent, so x to the fifth, and divide by that same exponent. And putting x to the 0 here instead of a 1 makes that process a little bit easier. Although I would suspect that pretty soon you're going to get used to this and be able to do this without necessarily that little crutch. When it's all said and done, don't forget the constant of irritation, also sometimes known as the constant of integration. Let's clean this up a little bit. 16 fifths, x to the fifth. 3 goes into 24 8 times. Plus 9x plus a constant. Yay. Now, if I was really concerned about doing well on an exam, and I wanted to know that I got this right, how could I check it? Yeah, if you differentiate this, you should get back to where we started, which was this, which factors into 4x squared plus 3 quantity squared. So you can and should maybe check these. Let's keep going with problem number 26. Unless there's some questions on problem 22 here. All right, so problem 26. The integrand is secant of y times the tangent of y minus the secant of y again. And this time our differential is dy. I do appreciate if you keep that differential around. I start getting a little uneasy if people forget that. Kind of like the last one, we need to find some antiderivatives for the integrand. There's no product rule for integration, or at least not one that we're going to get this semester. And the one that you eventually do get is a little bit different than what you might expect. So we need to turn this into something that I can find an antiderivative of. So let me simplify this by distributing the secant of y. Secant of y, tangent of y, minus secant of y, and that secant is squared. Let's look at these things term by term. Is there anything that you know of that when you differentiate it, you get the secant times the tangent. Yeah, just the secant. So the integral is going to be the secant of y minus, what do you differentiate to get secant squared? Tangent. Thank you. So secant of y minus tangent of y plus a constant. Nice. I'm afraid that's it. Wait.
That was easy.
There you go. All right. Let's try some different ones. Kind of a different look at some of these things. Problem number 36. Problem 36 gives us our first look at what's called a differential equation. So what's up with that? Well, they tell us that f prime of s is equal to 10s minus s cubed. No, 10s minus 12s cubed. And then there's this little side note, kind of comma, and they're saying that, oh, well, f of 3 equals 2. So let's see if we can't figure out what's going on with this one. Our goal in this is to figure out what f equals. We don't know what f equals. We know what its derivative equals. So at least that's a little bit of a head start. Its derivative is 10s minus 12s cubed. So how do I find the actual function itself if I know the derivative? Yeah, take the antiderivative. What the process that undoes differentiation is integration. So f of s is going to be the integral of f prime of s ds. These two things are opposite operations. They cancel each other out. So if I differentiate a function, then find its antiderivative, they're canceling each other out to within a constant anyways. So let's take a look at what the integral is going to look like here. The integral of 10s minus 12s cubed ds. Let's see if we can't figure out what that is. Well, let's see. It's going to be 10. What's the exponent that's understood to be here? A 1. If I add 1 to the exponent and divide by that same exponent, it's going to be 10 s squared over 2 minus 12 what? Good. S to the 4th over 4 plus a constant, and that's my f of s. Let's just, yeah, I was going to say we can clean this up a little bit. Let's clean it up as 5s squared minus 3s to the 4th plus our constant. Well, in this one, we actually really need the constant because we're not quite done with the problem. One thing that you'll come to appreciate about mathematicians and math problems is that they typically don't waste any words. All right, and this problem is no exception. They give us that f of 3 equals 2. And what that's going to allow us to do is figure out what this constant is. So we actually still need that information, and we need that constant. Let's see how that plays out. They're telling us f of 3, which would be 5 times 3 squared minus 3 times 3 to the 4th plus c, f of 3 equals 2. Okay, looks good. On the left-hand side, 9 times 5 is 45. 3 to the 5th is 243, plus a constant is 2. So it gives me minus 198 plus c equals 2. And isn't that special? C is an even 200. It's beautiful. Let me pause for a moment. Okay. Overall, f of s, now that we know exactly what c is this. 5s squared minus 3s to the 4th plus 200. Nice. But what allowed us to solve for that was this extra piece of information that helped us figure out what that constant was. Yeah, if that wasn't given, then the best we could do is just leave it with a C. Okay, how are we looking on those first couple problems?
I have a question.
Please.
For finding 5s squared minus 3s to the fourth plus c, if I was to do that in my head, is that like acceptable or no?
Yeah, what I need to see is some work.